G'day, my name's Steve and this is Reevesy Workshops. Today we're going to continue on with building the tanks for the Garratt. So this is the Garratt part 2. So a little trip to Bibra Lake this morning to the supplier, and I was able to get the angle that we need. Next step is to carefully mark it out. And what I'm doing is I'm using a pencil to scribe a line for the hacksaw blade, very carefully labelling it all so I don't get things mixed up either. And I'm cutting each section about 2 millimeters over length so I can trim them back to size on the milling machine. So here we are on the milling machine. So I'm just going to trim the edge 0.3 of a millimeter just to clean it up, and then we'll measure it. So I'm using my digital vernier to get the length. The drawing says I should be 132, and you can see I've got 0.27 left to take off. So back into the mill it goes. You may be wondering, what am I going to do to measure pieces that might be longer than the vernier? Well, it just so happens that not too long ago I was given this very nice vernier caliper from a craftsman that used to work at the State Engineering Works many years ago. And as you can see, it's not digital, you have to do it the old-fashioned way. And in a future video I'll show you how to use instruments like this. Of course, for those that don't have one of these, you have to use a ruler, which is nowhere near as accurate, but in this particular application a small error wouldn't matter. Some of the angles are in corners, so that means I need 45-degree angles on them. So I've set the vise up at 45 degrees on the milling table, and now I'm going to use the mill to cut these angles accurately. Here's an example of the finished result. Two of the angles are going to be required to be milled down from 20 mil to 14 mil on one side. So the vise has been put back square, and now it just becomes a simple milling operation. I won't bore you by doing a full-length cut on video, but you'll get the picture. The next operation on the angles is to drill and tap the holes. Now I've got a bit of a dilemma here. My mill drill is belt driven. It doesn't have a quick change gearbox on it. So what I've decided to do is set it at its lowest speed, 65 RPM. Trouble with that is the edge finder doesn't work properly and is not giving me an accurate test. So how do you get around that? Well, I have a small reamer that I use for my smaller engines, so you know it's been ground true, and it has a point on the end of it. So the camera is looking through a magnifying glass onto a brightly lit edge of the angle, and from there you can see my little reamer pointing right on the very edge, and I can now zero my digital readout and work from that. Not as accurate as a edge finder perhaps, but in this application more than accurate enough for what we want to do. With that sorted out, next thing I decided to do is just to pre-mark the holes in their rough locations using a ruler, a lead pencil and my calipers, just to mark everything out. Highlight them with the lead pencil I should say. Gives me a pretty good ballpark figure of where the holes should be. Of course the digital readout will put them exactly where they should be. And this method also helps me from making a mistake and drilling and tapping a hole in the wrong place. So the next stage is we need to work out where the holes are going, and that's going to need a little bit of maths. You can see on the drawing here the first hole is 15 millimeters from the edge. Then it says we need 8 holes at 26. And then our last hole is at 25 millimeter spacing. So what I've decided to do is we'll go 15. Then I'm going to reset the digital readout to 0, and then I'm going to count the 8 holes at 26. So we've got 26, 52, 78 and so forth, right up to the second last hole. Then we add 25 instead of 26, and that gives me 207. I've checked that against the ruler and those lead pencil marks, and it's all looking good, so we'll give it a go. Next step is to start center drilling it all. You'll notice I've got the angle sitting on 2 thin parallels to keep it all square and vertical, horizontal I should say. And I use the thin parallel so I can drill a hole all the way through and I'm not going to damage anything. So a little bit of cutting oil. I'm not going to worry about changing the speed due to the belts, as I mentioned before. So we're just going to center drill first and then follow up with the drill. That's the 15mm hole, so we'll zero the digital readout and move along 26mm. .8, 25.5, 0.9, 26. And now I'll repeat that for the full length of the piece of angle. I misread the drawing a little bit. It says 8 spaces, not 8 holes. So that means 8 spaces, 9 holes. But I picked that up, made the adjustment on my little chart, and then we can see the last hole is meant to be 10 millimeters from the edge, which it is. Now we can go ahead and drill, as I said before. Now I've brought the table back to the 0 point, which brings me to the first hole. A little bit of oil everywhere, as you see, and I can start drilling. Once again, the speed really is too slow for this drill, but you can see it's drilling, and I'm not meeting a lot of resistance, so I'm happy to drill the hole at this speed. With the holes drilled, now we can start tapping them. This stainless steel is pretty tough, but we're getting there. I've just got back from the sheet metal workers today. He's bent up all the bits and pieces for me, so I've temporarily put it all together. Give you a bit of an idea of what the finished product is going to look like. Starting to look a bit like an engine now, and I love the little water tanks, filler lids, brilliant. Several of the angles are quite long, and you can see they extend way beyond the width of the vise, and also they're long enough that they extend beyond the travel of the table, yet I've still got to drill and tap holes. How do they get around this? Well, first of all, I put the angle in such a manner that I could tap as many holes as I possibly can, and to stop them flexing, you can see that I've added these machinist vices, machinist jacks I should say, one on each side, and these enable me to keep the angle stable. The next thing that I've done is I've drilled and tapped as many of the holes as I possibly can within the travel of the vise, the milling table and the movement of the vise, except for the last hole, which I just left as the tapping hole. I then grabbed a gauge pin, put it in the chuck as you see here. That's the same diameter as a tapping hole. That enables me to slacken off the vise, and I can move the angle down very carefully, 3 holes until it matches. I can't actually put the gauge pin in the hole because I've already threaded it, so I'm showing you the operations after I completed doing them. But you can see that that pin will locate that hole very accurately. I can then tighten my vise up, set my digital readout to 0, and now I can move along and do the last hole. And you can see I've put a M4 button head bolt in there just to try it out. And that worked, and that enabled me to do things accurately. I've now made enough of these angles to start fitting things together, see if there are any unforeseen flaws with the design and the setup. I'm very pleased to say that everything is going well. There's no doubt about it, being able to use a digital readout on your milling machine means that these are all exactly at the right distance, and as a result of that they're going to match up with the holes already set up by the laser cutter, and this produces a good fit. So we've got these two pieces of angle matching each other, they don't interfere with one another. It all fits together very well, so I'm very pleased with that. One little design flaw that got picked up, however, was some clearance issues. So you can see the corner of this angle is overlapping the corner and area of this angle here. So I've had to go and cut 3mm off that edge there to enable this angle to fit on top of that one. I suppose you could call that a design error, but something you got to watch out for when you fit things together. Making things is the easy part, but getting things to fit together and work, well, that's the second part of the story, and this is a good example of that. But apart from that issue, you can see it's all fitting together very nicely. Another little clearance issue is here, where just the radius of that angle was just touching on there, so I just ground a little bit out on my linisher. Other than that, it was fitting okay. One thing that did surprise me, however, is although these holes have all been laser cut, there is a certain amount of tolerance with a laser, and maybe that has to do with the way it cuts the material. So a couple of these screws were a little bit of a tight fit to put in, and I needed to just elongate the hole just a little bit to free them up. But other than that, it all fitted together really nice, and you can see that it's square, it's all upright, it's all doing the things that it should be doing. And between using a laser cutter and the digital readout on your milling machine, it really does make this job simple. Much better than the old method of using a ruler, a scriber and an engineer's square. Another thing that I have to work on are these dummy little wings that I've put on the tanks to simulate the shape of the Garratt. Water tanks as they were, they had a bit of clearance in the middle there for the smoke box door. You can see that the metal has stretched as it is bent. You can see it in the circle there. It will actually stretch and move, so it never stays in a perfect place, and it's just a little bit too long, so I'm going to have to trim the edge, the back edge of it, and adjust the mounting holes to pull it back into line. You'll see also there's no mounting holes on the front here because we didn't know exactly where they're going to be until after the material has been bent and cut. But that'll be done next after I finish the angles. I got the base of the tank back from the sheet metal worker today. He TIG welded the bushes and the pins in for me. There was a little bit of warping of the stainless steel, but as you can see, it's all come together very nicely indeed. And as you can see, I'm getting pretty close to finishing this first tank. So it's looking good. Here's an inside shot for you. You can see this beautifully TIG welded bush sitting in the middle there. Down the bottom here, another bush and some of the pins. And I'll just show you some of the other plate work. You can see the idea of the design where the angle bolts everything together. And here's one of the front wings that I was talking about earlier, temporarily in place. So it's looking good. Before I go any further, I want to drill the holes for the pins and the bushes for the front tank to sit on this floor. So I've made up this cardboard cutout just to double check I've got the holes in the right places. Of course I can measure it straight off the drawings, but the pins are actually crooked, as when they're welded up they're not exactly sitting vertically. So I'm going to have to enlarge the holes slightly, and that means the positioning of the holes on this plate will be slightly different. You can see here, I'll just show you this pin, what I mean by that. So the hole has to be elongated just a little bit for that pin to sit in place. Similar story with other bushes. So what I'll do now is I'll make the holes slightly bigger in size, and I'll just minutely change the positioning of the holes to suit. To punch the holes out in the cardboard, I've made up these one-off brass dies. Of course a proper die would be made out of silver steel and hardened and tempered, but it gives me a clear enough hole to do what I need to do. You can see the one there for the big one, and of course you can see the hole's not quite perfect because these dies are a little bit crude, but as I say, it'll give me what I need, and so I didn't go to the trouble of making up proper ones. To use the punch, what I do is I use this base one, which I'll place under the piece of cardboard where it's all marked out. This one actually does all the punching, and I just tap it with a hammer. It'll punch through the cardboard and make the hole. Similarly with the other one, I'd put the cardboard over here and this goes in. You can see there's a little bit of a gap there. I didn't worry too much about making it a close fit, which you would normally do, as I just want to get a general idea of where the hole is to go. It doesn't have to be perfect, which you would have to do if you're making gaskets, for instance. Work on the front tank is progressing well, as you can see. So I think we'll finish this week's video here. So I'll catch you next time.